right, so the last problem for this lesson is use any strategy to solve the following division problems. So for A, we have the opposite at 2 and 1/8 divided by 1/3. For Bravo, it's negative 1 3/4 divided by negative 2/5. So I decided with these two, I would only have us practice using A, and then we're going to answer Charlie afterwards. And so the first thing that we need to do is, and I discovered that we need some extra practice on, is converting this mixed number into a fraction greater than 1. And so that's the first step that we're going to do. I'm going to go ahead and turn over my page right here, my notebook. Oh, fiddlesticks. There we go. Okay. So the first thing that I'm going to need to do is I'm going to need to change that into a fraction greater than 1. And so I'm going to do that up here. There's a few ways I can do that. We have done generic rectangles. I'd have to draw 3 of them. Seems like a lot of work, but I could do that. There's also a shortcut method that I could use, but instead I'm going to use the one where you can see what's happening and understand what's happening, hopefully, with it without having to have a bunch of drawing. So I'm going to take this number right here and I'm going to decompose it. I'm going to pull it apart. So I have my whole number, which is 2 here, and I have my 1/8 right here. So the first thing that I need to do is I need to take my whole number and I need to change it to a fraction. And so every denominator for a whole number, the denominator is going to be 1. We just don't write it. Oh, good gravy. Then we're going to multiply by a giant 1 because we need a common denominator before we add it to the 1/8. And so a common denominator between 1 and 8 is going to be 8. So we're going to multiply this by 8 to get to 8. Up here, the number that needs to be here, they have to match, remember? So it's going to be 8 because 8 divided by 8 is a giant 1. Now we have 2 times 8 is 16. So 16 over 8 or 16 divided by 8 is 2, so that's good because they need to be equivalent. But now we're going to add these two parts that we decomposed earlier. We pulled them apart. We need to recompose them, put them back together again. So 16/8 plus 1/8. My eighths stay the same. And I'm going to add my 2 numerators. And I'm going to get 17/8. Now don't forget, this guy's negative though. Don't forget that. So now this is my fraction greater than 1. So I have negative 17/8 that I'm dividing by 1/3. Now this is a spot what I told students in class that they needed to pick their favorite method. Either Madison's method or Huey's method to divide these two fractions at this point. And so I want you to stop the video right now and I want you to try to use either a common denominator to divide these or to make a supergiant or a super fraction and multiply by the reciprocal and a supergiant 1 to be able to divide these two fractions. So go ahead and do that now. Okay, so the first one that I'm going to do is Madison's method where I need a common denominator. So I'm going to do that over here. Hopefully I have enough space to do both. So let's try this out. So I have these two. So I have negative 17/8 and I have 1/3. I'm going to multiply both of them by a giant 1 so that I get a common denominator. And so with both of these right here, the way that I find a common denominator is I ask myself, is there anything that I can do? Oh, that 3 looks pretty rough. There we go. Can I multiply 3 by anything to get to 8? Nope. Okay, so 8 times 2 then is 16. Can I multiply 3 by a number to get also to 16? Nope. So because of that, that means 8 times 3 is going to be my lowest, or my LCD, which is my lowest common denominator. I don't usually say it that way. So we have 24ths here, 24ths here. And again, I can have bigger numbers, but that means I have to reduce, and that's more work. Less work. We want less work. We have to do enough work without doing extra. So 3 times 8, 8 times 3. Up here, my 3 should also be up here. And down here, my 8 should also be up here. I'm going to start with this guy, number 1, because it's easier. 1 times 8 is 8. Up here, I have negative. Ooh, I better write that right there. I have negative 17 times 3. Now, most of you know I don't like to just go over here and do a bunch of work. That's not my thing. So the first thing I do is I'm looking at this. I don't know if I can do it because it's written so small. Is I look at 10 times 3. What's 10 times 3? It is 30. Okay. And then what's 7 times 3? 7 times 3 is 21. So if I add those together, I get 51. So I just broke apart the 17 into 2 different numbers and added them back together to make it easier because I don't want to bust out my calculator. Okay. So now we have these 2 fractions where we have a common denominator. So my problem now is negative 51 24ths divided by 8 24ths. Again, in this method, I just cover up that denominator and I really have negative 51 divided by 8, which equals negative 51 eighths. Can I change that to a mixed number? Oh yeah, I can. Do I have to? Instructions didn't tell me to. I can leave it alone. So for Hui's method, in contrast, we're going to make a super giant one. Again, I'm using this part right here. I'm not going back to the other guy because that, again, I don't want to do work twice, even though I'm doing the problem twice. I guess that is a little ironic. But anyway, I think it's because it's getting late. I have negative 17 eighths divided by 1/3. I'm now going to multiply by super giant 1. To make this a 1 and get it to go away, I need to multiply by the reciprocal or the multiplicative inverse, which is, whoop-shoo, 3/1. I'm going to do the same thing right here. And now the problem should look very familiar to you. We have, again, a 1 right here. I have negative 17 times 3. That's going to be negative 51. If you want to see where we got that from, that was over here, remember? I would do it the same way on this problem. Over 8. Now we have negative 51 over 8. Okay? So whichever method makes the most sense to you is the one that I want you to use.